Hello everyone, welcome back to another Science for Breakfast video. Today we're going to conduct an exciting experiment to explore the concept of heat transfer by infrared radiation using a Leslie cube and an infrared thermometer. Before we delve into the experiment, let's take a moment to understand why different surfaces emit infrared radiation differently. You see, every object with a temperature above absolute zero emits infrared radiation. Now, the rate at which an object emits this radiation depends on its surface properties. Surfaces that are dark and matte, like the matte black side of our Leslie cube, tend to absorb and emit radiation more efficiently than lighter, shinier surfaces. So how do we measure this radiation? That's where our trusty infrared thermometer comes into play. An infrared thermometer works by detecting the infrared radiation emitted by an object. It contains a lens that focuses the infrared radiation onto a detector, which then converts this radiation into an electrical signal. The thermometer then calculates the temperature of the object based on the intensity of the infrared radiation detected. In our experiment, we're using the infrared thermometer to measure the temperature of each side of the Leslie cube. This allows us to quantify how different surface properties affect the emission of infrared radiation. Understanding how different surfaces emit infrared radiation is not only crucial for experiments like ours, but also finds applications in various fields such as industrial processes, thermal imaging, and even medical diagnostics. Now that we have a better understanding of infrared radiation and how our infrared thermometer works, let's start the experiment. First, we'll fill the Leslie cube with hot water. This will allow us to observe how different surfaces on the cube emit heat. To ensure accurate readings, we'll insert the bung into the Leslie cube to minimize heat loss by convection. Next, we'll measure the distance between the infrared thermometer and the Leslie cube. This will serve as our control to maintain consistency throughout the experiment. Now let's record the temperatures of each side of the Leslie cube. Remember, it's important to do this quickly to ensure accuracy. A quick word of caution, the Leslie cube can get quite hot, so be careful when handling it. The matte black side of the Leslie cube is recording a temperature of 85.1 degrees Celsius. The shiny copper side is emitting much less infrared radiation, measuring at 30 degrees Celsius. The shiny white side is registering a temperature of 80 degrees Celsius. The shiny black side is at 83.8 degrees Celsius. In conclusion, we've observed how different surfaces on the Leslie cube emit heat at varying rates. This experiment highlights the principles of heat transfer and the importance of surface properties in influencing temperature. One improvement we could make for future experiments is to use a heat-proof mat underneath the Leslie cube to ensure safety and prevent heat loss by conduction to the table. And there you have it. Thank you for joining us for this experiment. Don't forget to like, share and subscribe for more exciting science content. Until next time, stay curious.